Bismillahirrahmanirrahim. In this session, we will discuss exercise 9.10, question number 5 to 7 from additional mathematics course. This book is written by Sue Pemberton, which is very popular. The topic is trigonometry, and here we have question number 5. Part A, solve the equation 2 cosec x plus 7 upon cos x is equal to 0 for the range of 0 to 360 degree. The value of x is varying from 0 to 360 degree. So here we have 2 upon sin x plus 7 upon cos x is equal to 0. We take the LCM and sin x cos x, and this sin x will divide this and cos x will be obtained. So multiply this 2 with cos x like a simple LCM. Similarly, for this cos x, we will divide this denominator and we'll get sin x, and then sin x will multiply with this 7. So this becomes, so we have performed LCM here, and 2 cos x plus 7 sin x divided by sin x cos x equal to 0. Now we will multiply this denominator to here, and this cos x plus 7 sin x is equal to 0. So from here to here we have obtained 2 cos x is equal to minus 7 sin x. Now we will shift this cos x here and minus 7 here. Then sin x upon cos x is equal to minus 2 upon 7. From this part to this part, we can just crossing the sine or cos from one side to other, and we will have this expression, this equation, transformation from here to here. So simple manipulations, and we will obtain this. This sin x upon cos x is equal to tangent, so we will write in place of this sin x upon cos x, we can write tangent x. So tangent x is equal to minus 2 upon 7. From here, this x is equal to tangent inverse minus 2 upon 7. So we have to obtain the value of tangent x where the value is minus 2 upon 7. We know that tangent is negative in second and fourth quadrant. In a first and second quadrant, tangent is positive. So we will take from the calculator by placing it in on a degree to make sure that the selection is on degree. So from where we will obtain this 164.05 degree and at 344.05 degree, because this is the fourth quadrant and this is second quadrant. So this is our answer. So this was required in exam, but in order to prove that there are two solutions, I have plotted it for 0 to 360 degree just for better understanding or improve the visibility of this problem. This is a superfluous requirement. It is not required in the final examination, just for practice or better understanding. So this plot tangent x is equal to minus 2 upon 7. We have plotted it and we have obtained this for 0 to 360 degree. We have plotted this tangent x. So this is tangent x, right? From 0 to 90 degree it will increase, and after 90 degree it will rise this again, and at 270 degree up to 220 degree it will rise, and after that at this value from after 270 it will again increase to this value 360. So this is simple tangent graph we have plotted, and there is another value minus 2 upon 7. So at minus 2 upon 7 we have draw a straight line, and we see that this tangent x is crossing minus 2 upon 7. So we can see that this minus 2 upon 7 line, the tangent x is crossing at this value, which is 164 point something. We can see it here, and at 344 here this is crossing. So this is this point is our solution, and this point is our solution, which is in the second quadrant, up to 180 degrees from 90 to 180 degree here. This is second quadrant, and this is from 270 to 360. This is fourth quadrant. So we can see here there are two solutions. So we have verified it by the plotting that our solution is correct. So whatever required in the examination is from here to here. So that's it from this question number 5. Now part A. Now question number B. Solve the equation 7 sine 2y minus 1 is equal to 5 for value of y for 0 to 5. Here the values are given in radians rather than degrees. It is given in radians. So 7 sine 2y minus 1 is equal to 5. So we can place 7 from here to in the denominator, cross side crossing. So we will divide this equation on both sides, divide by 7. So we'll obtain this result. And then 2y is equal to sine inverse 5 upon 7. And we know that sine is positive in first and second quadrant, and afterward it will repeat. So this is first and this is second quadrant, and since this 5 radians is at this value, this is also because 2 pi is added with this one and 2 pi is added with this one, we will have this solution. But up till now this 5 radians, so this solution will not be required for this value, but we have this 2y minus 1, so that's why we have obtained, because we will subtract something from here. So when we subtract it from here, we will have a different result. The plus subtract 1 plus 1, and then we'll divide this by 2. So we have to obtain the value of y, not this 2y minus 1. So that's why we have considered this 2 other solution as well, because we have been given range of y. So we have to plot it for the range of y. So that's why we have taken this extra one that will reduced once we proceed. So 2y minus 1 is obtained as this fourth solution. This is quadrant 1, this is quadrant 2, this is quadrant 1, and this is quadrant 2 after completion of whole revolution. After completion of whole revolution. So if 2y minus 1 is this, we will shift this 1 and add 1 here. 2y is equal to, this becomes 1.795, this becomes 3.346, this becomes 8.078, and this is 9.63. 2y is equal to 9.63, and after that we will divide each number by 2. So this 1.795 becomes 8.8975. This 3.345 divided by 2, we will have this 1.673, and this 8.078 will divide this by 2, so we will have 4.039, 9.63 will be obtained as 4.815, and here we can see that all value of y is less than 5 radian. So these are all solutions. So this the trick was this one. So we have taken this solution and we obtained value of y is less than 5. Because of this information, we have taken this. So this is very important part, and since it is available, it was a part of the examination, so it was not easy, though it's not very complex. So we have to obtain the solution up to here, but I have plotted it on the paper just for better understanding. So here is the solution, and whatever we have said in our statements, we are just showing it here. So we have to plot this 7 sine 2x minus 1. So we have plotted this 7 sine 2y minus 1 for the range of 0 to 5, and we have draw a constant line 5 and compare this graph with this 5 here. So this is our sine 2y minus 1 graph. So we have to start it by 0. At 0, this graph is plotted, and from 0 to here at this point, this is from here to here, we have this quadrant 1, this is quadrant 2, right? And then this is quadrant. So it's shifted. We have also this, we have obtained this solution, but after that we have manipulated it. So once we manipulate it from in terms of y, because this is obtained in terms of 2y minus 1, and we have to obtain in terms of y, so we will manipulate it. So after obtain these values in terms of y, we will manipulate each values with this plus 1 and divide by 2. Plus 1, this plus 1 divide by 2, this plus 1 divide by 2, this plus 1, because we will shift this to here, plus 1 divide by 2. So we will obtain this, and at these points the values are our solutions. So at this point we have 0.8975. So So we can see this here, at this value is 0.8975. At this value, this is 1.5, we can see this is 1.673, this, and similarly this is 4, so this is 4.039. Similarly, this part is 4.815, so this is 4.815. So here we have 1, 2, 3 and 4. So there are 4 solutions, and we have plotted and showed it on the graph, and showing it on the graph. So this is very, very important. So we have plotted this graph and equated with 5. So we have plotted this left hand side as a blue graph, and this red is 5 here, and just equate it and obtain this. So this is simple. Now move on to question number 6, part A. On a copy of the axis below, sketch 0 to 2 pi. So we have to sketch this y is equal to cos x minus 1 and y is equal to sine 2x on the same graph. So y is equal to cos x minus 1. So we have for the range of 0 to 2 pi, so we have taken 0, pi by 6, pi by 3, pi by 2. So we added pi by 6, then add pi by 6 to get pi by 3, add pi by 6 to get pi by 2. Similarly, with an interval of from 0 to 2 pi, we have taken values pi by 6 with the interval of pi by 6 and obtain the cos x as these values. So cos x, and we have to plot cos x minus 1, so we will subtract minus 1 from this value, so we will have this one. So this is cos x. At 0 we will have cos x minus 1 is 0, pi by 6 we have plotted this value, so we have plotted this cos x minus 1. So we will plot this x and this row number 3. And similarly, y is equal to sine 2x. At 0 it will be 0, pi by 6 it is 0.866. At pi by 3 this is again 0.866. So because this is pi by 6, so this pi by 6 becomes 2 pi by 6, because this pi by 6 here, x in place of x. So this is pi by 3 here, so this becomes 2 pi by 3. At pi by 2, in place this pi by 2 here, in place of x, this becomes pi. Sine pi is 0. So that's why sine 2x becomes 0 at pi by 2. So this is obtained here. Now we are plotting it. So cos x minus 1, so this is cos x minus 1. Sorry, this is blue is cos x minus 1. So at 0 we have this 0 here. At pi by 6 we have this value, which is minus 1.134. This is pi by 6. And at 0.5 here, sorry, pi by 3, at pi by 3, this is pi by 3, the value is minus 0.5. At pi by 2, the value is minus 1. And this pi by 2, the value is, this is minus 1. This is 2 pi by 3 the value is minus 1.5. Similarly, the whole graph is plotted and eventually the value is 0, and this is minus 0.134, minus 0.134 here. So this is symmetry here at pi. If we fold it, this part to this part at this position, it will overlap. If we flipped it from the left side to the right, if taking this as a axis, we will have a same graph, same pattern. So sine 2x is plotted here. At 0 its value is 0. At pi by 3, this is pi by 3, this is pi by 3, this is pi by 6, this is pi by 3, same value you can see. At pi by 2 the value is 0, yeah, pi by 2. Similarly, this is pi. At pi this is 0. At 3 pi by 2 is 0, and between this is value is this, and then at 2 pi is again 0. So this is sine 2x, and this is blue curve is cos x minus 1. So we have plotted it. Simple. Now this is part A. Now part C. State the number of solution of the equation cos x minus sine 2x is equal to 1. So if we shift this 1 is here, and this cos 2 sine 2x is equal to on the right hand side. So this becomes the equation. This on one side we have plotted cos x, on the other side we have plotted sine 2x. So this is the same as these two equations, one on the left hand side, other on the right hand side. So we can write down this value as a cos x minus 1 is equal to sine 2x, and which we have already plotted in a part A and B. So we can see the number of solution. So we see that this curve is intersecting at 0. So at 0 this is 0, both the values are 0. So this is a one solution because both are equating. And at 2 pi by 3 and 5 pi by 3, between these two values, here at this point it is intersecting. So this is a second solution from the graph, it is available. And at 2 pi is 0 0 because these both are equating. So this is again a third solution. So there are three solutions. So we can see it from the graph that there are three solutions, which is the part C. So it was simple. From on the basis of this part A and B, this question has been asked because this is 1 marks question, but it's not very easy if we don't have a proper concept. So this shows it here. So this is very simple, and if we understand it well. So this is question number 6. Now question number 7, we have to prove that 1 plus sine theta upon cos theta whole square plus 1 minus sine theta upon cos theta is equal to 2 plus 4 tangent square theta. So taking left hand side, and we will prove it that this left hand side is equals to the right hand side. So we have taken this left hand side, and from this we have open it. So this becomes in the numerator, in the denominator this is cos square theta, in the denominator it is again cos square theta. So we take the LCM and we'll open it. A plus b whole square, so this is a plus b whole square. A square plus 2ab plus b square. This is a minus b whole square. A square minus 2ab square and b square. This is cos square theta in the denominator, cos square theta in the denominator. So we take the LCM and we write down this. So we skip one step here and write down directly. If we know it well, we can save time. Now we have this 2 sine theta and minus 2 sine theta, so it can be eliminated. So this is 1 plus 1, 2, and this is sine square theta, 2 sine square theta. So we can write this as a 2 upon cos square theta and 2 sine square theta upon cos square theta. So this is 2 sec square theta and this is 2 tangent square theta. We can write this sec square theta as a 1 plus tangent square theta. In place of this, we can use identities and write 1 plus tangent square theta in place of this sec square theta. So this is 2 plus 2 tangent square theta plus 2 tangent square theta. So this is 2 tangent square theta plus 2 tangent square theta. So 2 plus 4 tangent square theta. This is our right hand side. So we have proved it that left hand side, we have taken this left hand side and obtained our right hand side. So this is obtained here. So this was question number 7, which was the part of the IGCSE exam in 2013. So in the next session we will discuss question number 8.